Compañero, welcome. My name is Carlos El Chacon, and my podcast aims to bring you together with others working with SQL Server and engage in conversations to share ideas, meet old friends, and make a few new friends along the way. I call it the SQL Trail. Thanks for joining me.
SQL Data Partners.
Compañeros, welcome to the SQL Data Partners podcast. This is episode 134, and it is good to have you on the SQL Trail again. Today, we're talking about CosmosDB. So the the database platform, that Microsoft introduced in 2017, which admittedly took me aback a bit, but is very cool. And obviously, they're looking to integrate with the Azure services that are available. And so today, we have with us Sidney Andrews. So Sidney's been doing quite a bit of work on the training side of Cosmos, and he is the owner and operator of C#Run.net. He's actually locally here in Richmond, Virginia, which is how I know him. And he's been doing quite a bit on the training front. So he's been speaking at Ignite. He does many courses on the Microsoft Virtual Academy and has several courses on the edX site. So we're excited to have him and to be talking with him about Cosmos, what Microsoft is doing with it, and how it might relate to those of us who know and love SQL Server. We also have Eugene Meininger and Kevin Fiesel on the program today. So Kevin, one of the things we're doing is we're inviting
the best of the best.
Yes. We are trying to get the best of the best here on the SQL Data Partners podcast.
But you couldn't find them, so you had to settle for me. That's fine.
Yes. And so we wanted to talk a bit about, remind folks who you are, what you're doing, and things that you might be talking about on the podcast.
Sure. So I'm Kevin Fiesel. I'm a data platform MVP. I run a predictive analytics team out of Durham, North Carolina. I'm focused heavily on Hadoop R and basically everything in the broader data platform, which means I don't have enough hours in the day to do much of anything, it seems.
There you go. And you've come on the program to ensure that you get more episodes than Jonathan Stewart.
This is a big part of it, and also to evangelize F#. Everybody go learn F# because it's a great language.
Well, awesome. So Kevin, we look forward to having you on more episodes as a guest.
Absolutely. Looking forward to it.
Now, we're still working out this panel system, if you will. And so unfortunately, Kevin doesn't get a lot of airtime this episode, but we look forward to having him in the future. We do have a couple of compañero shout-outs as well. The first, Jeff Moden. If you've run into any of the internet forums, I know SQL Server Central, he's very active over there. And if you ever hear the term rebar, right? So row by agonizing row, then more than likely you have gotten into a discussion with Jeff Moden. And so we are happy to have scheduled some time to have him on the program in the future. So we're looking forward to that. Also want to give a shout out to Aaron Hayes, Douglas Kemp, and Clark Hahn, who I met in West Virginia. So want to talk a little bit about the SQL Trail. So what is the SQL Trail, you might ask? For those of you who are new to the program, tuning in for the first time, the SQL Trail is the East Coast SQL Server Conference. We are going to have the conference on October 10th through the 12th. Registration, I'm hoping to have registration open by the time this podcast is available. However, if not, it will be opening here in the next couple of days. But it will be held in Richmond, Virginia, 2.5-day conference. We have a mix of MVPs that will be coming in, but it is different from traditional conferences in that it will be much more engaged, and you will have an opportunity to both select and contribute to the content. Again, this kind of goes back to my Alan White quote, in that we all have something that we can learn from each other. And this is one of the goals of the SQL Trail. We will be breaking up into tracks this year, more than likely. We'll see, again, what the registration counts are. We are going to close registration at 40 registrants this year. And we're looking forward to having some labs, some hands-on labs that Friday. Unfortunately, those details are not yet final, but I think that you'll be very excited about what we have lined up for everyone for that Friday. So 2.5 days. We're going to start Wednesday at 2 p.m. Do some get to know you. We're going to have a great dinner that evening. Thursday will be, I won't say more traditional, but it will be sessions, content selected sessions that we chose on Wednesday, in addition to some of the content that our speakers or guests are going to be bringing to us, along with any other conversations that we want to be bringing up, questions that you might have, challenges that you're having, things like that. And then Friday, we'll be devoting a bit more to the hands-on labs. If you'd like to find out more, you can take a peek at SQLtrail.com. And again, we hope to see you in Richmond in October. So Sidney did give us quite a few notes and links to courses and other material for those of you who are interested in getting started with Cosmos. So we're going to include that on our show notes for today's episode. That's going to be found at sqldatapartners.com/cosmos or at sqldatapartners.com/134. And so with that, let's go ahead and jump into the conversation.
Hi, this is Kevin Fiesel, professional podcast guest.
Hi, this is Eugene Meidinger, business intelligence consultant.
Hello, this is Sidney, new to podcast, quite interested.
So Sidney, welcome to the program. It's good to have you.
Oh, thanks, Carlos. I've been wanting to come on for a while, and things just been so hectic. That's what happens when you work with a new database platform.
Yeah, that's right. We've been trying to get you on here for a little while. And of course, we're joined today by Eugene and Kevin. It's nice to have them on. So ultimately, our topic today is Cosmos database. Now, I think we'll get into a little bit of history here in a minute, but let me go ahead and start off by asking, why did Microsoft release a new database technology in 2017?
Okay, so that's a really interesting question. I'm not going to call it loaded because I like you. But the biggest thing here is it's not necessarily new. It's new to us. So internally, Microsoft has been using this database for a long time. It's one of the, it has some code names, but usually in traditional Microsoft fashion, the code name gets changed into something unreadable, undecipherable. But somehow the code name Cosmos made it out into the public, and that's the name of the database. Cosmos really is a different way of looking at databases and looking at accessing databases. And I'll almost say it's complementary to what you have with SQL. It's strong in some things that SQL is not strong at. It has some weaknesses to SQL. SQL is a very mature product that has a lot of strengths that Cosmos just isn't there yet. So I would say it's not new as much as it's a different offering for people whose requirements are slightly different than the traditional relational database.
Okay, so we know that Cosmos is what they call multi-model, but who's going to be using Cosmos? Who are the primary users of this database?
Okay, so I'm hesitant to use the term NoSQL because you hear the term NoSQL and it's a little bit loaded. You think of people who are anti-SQL. You think of database, like tons of database platforms with very little in common.
Sure.
So this platform is really aimed at people who have very specific data needs. So a really good example is that people who are using Mongo today, or people using Cassandra today, people using Gremlin. There's databases for those. Obviously, MongoDB, Cassandra has a database. There's tons of graph databases out there. But as you're already familiar with Azure SQL Database, Microsoft provides a complete database as a platform as a service offering. So no management, no infrastructure you have to worry about. CosmosDB takes that to the next level. What it really does is it says, hey, you want this database because of the features. You don't want this database because you just got bored at your office and decided you want to manage more servers. So you want graph functionality. You want to use Mongo. You want to use maybe the cool DocumentDB APIs or SQL API, JavaScript in your database. You want to use that, but you don't really want to manage things. So it's kind of a fully managed. I don't use the term NoSQL because CosmosDB is a little bit bigger than NoSQL. It's a multi-model database where you don't have to really go in and say, I need to configure servers, I need to configure partitioning and sharding, I need to go configure this. I think the audience is really businesses that are building a new solution or have a newer solution, and they don't want to take on the maintenance step of actual server maintenance. They want to actually use a database right away. So that's two different audiences right there.
Okay.
The first audience is these small companies who they're on another cloud platform. I'm not going to name any. They stood up MongoDB, which is just tons of JavaScript user groups in my area. I could tell you how many people have MongoDB stood up. And they hit 1 million customers, and all of a sudden the database is just not performing the way they want, and they have to scale. And the offering with Cosmos is really that scale is a configuration setting. You just configure it. You say, I want to be in these regions.
Sure.
I want to have this much throughput. I want to have this much storage. You configure it, and you're done.
Right. So you're taking advantage of the cloud offering, and particularly Azure here, and you get to choose your own adventure, if you will, from a hardware perspective.
Boom, you got it. So the big thing is, I like to say scale is a configuration setting. It's not a project anymore.
Sure.
I've been using any framework, I've been using SQL Server for years, but when I start talking about sharding and partitioning SQL Server, some people in the room, their eyes roll over because we know this is going to be a big project, involve a lot of people, a lot of planning.
Right.
And nothing against SQL Server. Again, I love the platform. It's just a different approach. Here, if I want to scale Azure Cosmos DB, I go in the portal, say, you know what, instead of 1,000 request units per second, I need about 10,000. And I cut a different check. So it's the same promise, platform as a service, just for the database world. That's one audience. The other audience I think that's going to be really interested in is these big corporations who are taking in massive amounts of data. So you think about IoT, gaming, e-commerce, where they're taking in ridiculous quantities of data and they want to be able to do stuff on this.
Okay. So now let's talk for a minute when we talk about multi-node. My understanding is it basically means that I can have graph data, I can have documents, I can have key value pairs, and all of these types or sets of data I can throw into Cosmos and it can consume those.
So it's really interesting. Let's take a step backwards because I know a lot of audience, this might be your first time hearing about Cosmos. Traditionally, if we have a database, we store the data in a certain way. And that way that we store the data, that's what's surfaced to our endpoints. So you have your TDS, tabular data stream protocol endpoint, and it surfaces the data in the relational database structure that you have. Well, Cosmos is a little different. Cosmos stores data in a specialized version of Atom format.
Interesting.
And then when you request data, decide to interact with it, two things happen. The first thing that happens is it actually shapes that data into a model. So think about it like real-time shaping. If you say, I need to access this data as a JSON document, it'll shape it into a JSON document. If I need to access it as a graph, it'll shape that data into vertices and edges. If I need to access it as Azure like storage tables, it'll shape it into that key value dictionary that you're used to. Then the API you use accesses the data in that shape. So those shapes I'm talking about, that's what we mean by models. So the document model, the key value model, the columnar or family model, and then graph model. Those are the shapes that Cosmos DB shapes data into.
So then I'm just interacting with it based on the data type that I want to work with at the moment. And I'm just going to feed it in, and then Cosmos is going to store it as it needs to. And so I want to just put it in as graph, but then you wanted to pull it out as one of the other types as a document or JSON. Then you could do that, but we're still looking at the same data?
Yes and no.
Oh, okay. There we go.
Today, you can't do that quite yet. You can kind of see glimpses of that. I'm dating the podcast here, but one of the things you can do in 2018 is you can go and create a SQL API with document model instance of Azure Cosmos DB, but then you can access it using the Azure Storage Explorer as a table API endpoint. I can open up MongoDB Compass and access that whole SQL API or document DB instance. All I'm doing is just taking the primary keys and the URL connection strings and rebuilding it into whatever connection string format that database expects. So that's the future of Cosmos DB. The product team's been very talkative about this at conferences. That's the goal. That's the dream at the end of the tunnel, is that you can just dynamically switch between models and types and APIs.
Gotcha.
Just not quite there yet.
Okay.
Because you got to imagine a really good example is like with Mongo stores data as BSON. But the SQL API, which used to be called Document DB, that stores data as JSON. And JSON and BSON don't have a one-to-one correlation. So what is the difference is, how do you serialize and deserialize between one of them? And the engineering team has a lot of really smart people on staff who literally, they're trying to solve that problem now.
Sure.
And that's the goal, yeah.
Okay. Well, so I think I just learned something. So that storage type, I guess one Mongo storing it as BSON. And then I always thought of JSON as, I don't know, just a different format almost. But you're saying that there is I don't know if protocol is the right word, but
I think you had the right word the first time,
okay.
Data formats. So BSON is a superset of JSON that's specific to the MongoDB. I'll give you a really good example. If you ever go through the Hello World tutorial for MongoDB, you'll notice that instead of putting an ID field that's a string or integer, MongoDB's ID field is of type object ID, which is a very special data type unique to Mongo. So BSON is really JSON with a whole bunch of Mongo stuff added on.
Okay. Yeah, so lots of different decisions, but I feel like all of a sudden, I'm well out of my comfort zone.
So speaking of decisions, let's pivot to one of the other major choices that you can make with setting up CosmosDB, and that is different consistency levels.
Yeah, they got like 5 of them.
Yeah, and it's one of the craziest things because I've been using Cosmos DB since back when it was Document DB and it was a little bit different platform. And this has been years now, but only 2 months ago did I really understand all the consistency levels. And that was because a product team member just sat me down and drew it for me. And I was like, oh, but essentially, strong and eventual is what we all know. If you go to SQL world, that's sync and async, replication. So strong and eventual is easy. The ones in the middle are compromises between strong and eventual, where you need strong in some situations and eventual in other. So a really good example is session consistency. Session consistency means within the context of this connection or session, we have strong consistency. But outside of this session, we have eventual consistency. So if you have strong consistency globally for your database, everything is synchronous and you have to wait for all replicas to commit before your data is available. So you have less performance relatively. You have multiple regions, multiple replicas. Session basically says just for this user session, this one user in their session or connection is going to have slower performance because they have to wait for all replicas to commit. But that's an acceptable sacrifice because we have scenarios where a user needs to see the same data. The example I always give is, let's say you have a mobile application and it's like a Zillow or something, and you're trying to upload your house and say it's for sale. If you put in your house information and hit the submit button, and this is a fully asynchronous eventual database, and we refresh the list of houses and your house doesn't appear, you think the application is broken. So what do? You fill out the form again. And all of a sudden you have 3 listings where you meant 1. So for that user in their session, I want strong consistency, but nobody else should see a sacrifice in performance outside of this session.
Interesting.
So you see, that's a really good example. Like it's compromises.
Right.
Now, I have a quick question on the strong consistency. I forget, does that impact your options for geo-replication and that sort of thing?
No, you still have your same options for geo-replication, backup, and restore, but you hit an interesting point on the head. If you have strong consistency and you have geo-replicated to multiple sites, it will have an impact on the performance of that request. Without getting too technical to 400 level detail, you're going to eat it as far as transaction costs. Yeah.
So that is interesting. I think as you bring up, it sounds like I can actually have different types of consistency within the database. So from a SQL Server perspective, I guess I can specify it to query. So at the query level, I could do with read uncommitted or something like that. I suppose that's very similar to some of that.
Yeah, you're absolutely right. This is one I just learned about a week ago. You can even specify a different consistency level for a specific transaction. So if you're using SDK from .NET, Node, or Java, you can say for this individual request, I want a different consistency level. Never came up in the real world for me yet, but it's there.
So what kinds of consistency models do you typically see in the real world?
Almost all cases strong is more than good enough. I try to push people towards eventual, but it's too much of a culture change. I like eventual, but I can't convince any customers to go there yet. In my world, we're talking seconds, minutes at most. This report is accurate as of 2 minutes ago is perfectly acceptable to me. So the larger the corporation is, the more I can push them towards eventual consistency and understanding the nature of asynchronous data. Session consistency seems to be my pit stop. So if I can get a company halfway convinced, I can get them to session and then eventual. So it's kind of like moving along the path. I do warn them, hey, if we're going to do strong consistency, understand that each request is going to transact more RUs. And so the aggregate, you may have to have a higher threshold ceiling of RUs per second.
Since you brought up RUs, just a quick comment on that. At least whenever it was Document DB, I found the pricing to be a little bit weird for, I guess, what's now called CosmosDB. So I did like a personal app to keep track of to-dos and that sort of thing. And one of the things that was strange to me was that everything went in a collection. And you had to price out the entire collection, what level of performance you wanted, that sort of thing. But it didn't seem like there was the idea of tables within that collection. You would think a database and a table. It seemed like it was just this big giant bag of data. And so the problem that I ran into was I'm coming from the SQL world and I was making this app to just keep track of to-dos and other things. And so I wanted to have the equivalent of tables and, to separate out my data. And at least whenever I was poking around with it, it looked like what I'd have to do was that I'd have to have some sort of flag or field in my documents that says this is what type of object it is. I had hoped that I could do different collections and treat different collections like tables, but the pricing model just didn't make sense for that. So I don't know if that's changed at all. It looks like you're still paying for RUs and data space or data storage. And so you kind of have to put everything in one big collection is what it seems like.
So 2 answers to your question.
Yeah.
The first answer is in Cosmos world, we have this whole hierarchical structure where you have your account. And then within your account, you have a database. And the database is just a logical container. And the database can have zero or many containers. In the document DB, SQL, Mongo world, we call those collections.
Right.
So a container is closer to your table than it is to your database. So what ends up happening in the Mongo world a lot is that Mongo developers will have 20 or 30 collections because there's a one-to-one correlation there between a collection and a table. And you noticed already that in the Cosmos world, you build based on containers or collections.
Right.
So containers are what they're called behind the scenes when you're API agnostic.
Sure.
Collection is just the name used for API. The problem you run into is that the floor of a container is too high.
Exactly.
There's a minimum cost per container. So if you need 30 containers, you're really eating it pricing wise. That's the number one question brought up in user voice. It's brought up at every conference.
Okay.
I'm really hoping they do something about it. Obviously, if I know something, I can't say anything about it.
Right.
But I'll say this. The product team is extremely aware that this is a huge limitation. And the way they found out, and this is really interesting, there's a huge market of people, like I talked about earlier, who do MongoDB and are ready to scale and figured out to scale MongoDB, you have to bring in like a $500,000 consulting firm and do a 1-2 year project with partitioning and setting everything up. It's pretty complex. So Cosmos is really interesting to them because they could say, oh, I could just use this service and let this service scale me out. And I don't have to change any code. It just uses the MongoWire protocol. The problem they ran into is just like we talked about. They have these containers in Cosmos, but in MongoDB, there's really no limit to the amount of collections you can have. So they have hundreds of collections, i.e. hundreds of tables.
Oh, wow.
And so what do? And the guidance up until today has been just to combine your collections, combine your tables, and use a field to separate between them. From a technical perspective, there's no downside to doing that. It's just the easiest way to solve that problem. Usually we have JSON documents and we have a field in that JSON document called type.
Okay.
I've seen people in .NET land, they serialize the name of their plain old CLR object and use that as a type, and then they get that serialization back, and that's how they know to get all records of a certain type. I've seen people partition based upon that type. So there's lots of ways to tackle that. I think the answer is the product team has to come up with a way for you to maybe pool or collect RU resources and spread them out amongst multiple containers. I think that's the answer. Maybe a lower floor, so there's an easier cost of entry to using Cosmos.
Right.
There's lots of ways to tackle that problem, but it's kind of the whole Microsoft thing where you create a new database and you have to serve these Fortune 500 customers. And then once the database matures a bit, you realize, oh, wow, it's too expensive for the average person. How many times have you seen that in Azure?
Right.
Now we got to figure out how to price this differently. And all of a sudden you come up with like 20 or 30 different pricing schemes. And I think we're at that phase of the growth where Cosmos is now trying to figure out how to be cost effective for all small to medium sized operations.
So what does one of those containers go for then? You remember off the top of your head?
I feel like it was like $10 or $20 a month back when I was looking at it. I forget.
Yeah, that's about right. That's for the minimum. If you're doing something like we're importing Mongo, we recommend 10,000 RUs per second for the import operation. A 10,000 RU per second container goes for about, let's say, 200 a month. So one of the things you can do, though, is you can dynamically scale your RUs. That's something a lot of people don't realize. You can assign, 10,000 RUs per second to do the import operation, then scale back down to 1,000 after you're done. And that's your regular running database. So if you need to do one-off operations, you can blow up the amount of throughput you have, perform that crazy massive operation all in parallel, and then just bring it back down to normal. I had a customer who did that because they do OCR scanning. They brought in all this raw OCR data and they wanted to pop into Cosmos. So we bumped them up to 1 million RUs per second and flooded the database with requests. They got a $200 bill for the couple of hours of operations, and then we just brought it back down to normal. So pricing is a little bit of a challenge right now because the database is definitely tuned towards customers who have millions of records, hundreds of thousands of transactions, tens of thousands of transactions per second. I think they got to take a step back and think about the small, medium-sized applications.
Quick question. I don't know if anyone knows this. With SQL database, aren't you able to pool your DTUs for that? Does anyone remember?
Yeah, so with Elastic Pools.
Exactly. That's
Yeah,
what I was thinking of. So hopefully at some point they have something similar.
I hope we get something similar for Cosmos.
Exactly.
Okay, so let's talk about interfacing here. Again, the SQL Server perspective, an R migration into the cloud. There's Azure SQL Database. At first, the very first versions, you could only really interface with it through the web browser. Now they'll allow you to connect through, SQL Server Management Studio. How am I connecting to Cosmos DB?
One of the interesting things is it based on your API. So if you're using a Mongo API, you use that MongoDB Compass or hundreds of other Mongo IDEs. If you use it on the Gremlin API, there's on Graph IDEs.
Well, we want to talk about, I'm a SQL Server guy. So what am I going to be using to connect to MongoDB?
See, that's where it gets really interesting.
You keep using that phrase, Sidney.
Because it is. Even for me as a developer, it took a lot of time and a lot of changing my perspective to really kind of understand what was going on. But from a DBA perspective, I think your interface is going to be the Data Explorer. The Data Explorer is in the Azure portal. And what it gives you the ability to run queries, to view your documents, to manage your index policies, to manage your scale, your RUs per second, all that within the portal. Even though all that's available via the developer SDKs and stuff like that, I think the portal is by far the best experience for this. And they're very portal first here. Rather than building a desktop tool to finish this, they just say, well, everybody else is in the portal. Why not just build it in the portal?
So I'm interested, Eugene. What was your experience when you were building your little app?
Yeah, it was interesting. So my little web app was like ASP.NET.
Okay.
What I did is for all of the testing, I was using the portal just to test out queries and play around with it. And then
Now, using the Data Explorer that Sidney mentioned?
yeah, I was using the Data Explorer, especially whenever I was adding in to-dos initially for stuff that was recurring and just playing around with the data. I was using the Data Explorer they talked about in the portal. But then for the actual code, I was using, actually, I think I played around with C# and I think I may have also used Angular a little bit.
Okay.
I forget. I think, if you're coming from the DBA world, you probably have a developer friend in your team that's very comfortable with C#.
Right.
So I have a feeling that's a very likely path to go down.
So every engineer I met on the product team are developers first. So it's a developer for database. Matter of fact, we all had to be convinced, including me, to create labs and document examples in .NET because they wanted to do it in Python. I wanted to do it in Node. And we were doing 400 level labs roadshows. And somebody came in and was like, are y'all going to write some .NET labs? And we were like, oh, yeah, this is Microsoft. Sorry. So, yeah, I use the C# SDK. And one of the things you'll find if you go to docs.microsoft.com, you look at the documentation, they actually have a web page that not a lot of people that I've talked to have ever seen until I mention it. It was the same thing for me. Product team mentioned it to me. I was like, oh, this is here.
They also have a good quick start tutorials. Whenever I was trying to get started with it, they basically had I think it was on GitHub, just a whole project you download, and it has code for a bunch of different operations. So it was easy to get started with. Something related to that, Cindy, I'm wondering if you had any experience with this, but I ran into some trouble where I don't know if I was just coding wrong and I'd get an error or I'd get throttled or something like that. Because it's cloud first, it seems like you kind of have to take a cloud first mentality with design patterns and build in kind of a retry model, just because you may not always be successful on the first try. Have you run into that issue at all?
Yes, absolutely. So there is a retry pattern baked into the SDK.
Okay.
But we highly recommend you roll your own retry logic. There's a couple areas you're going to run into. One of the most interesting ones is CosmosDB has their own HTTP status codes.
Mm-hmm.
They indicate certain things with the database, like you're hitting your throughput limit for transactions, or there's an error code that means you can have up to 10 gigabytes per partition key. And if you hit the maximum for your partition key, there's a specific error code for that. And so when you get your response object back, it actually tells you which status code you hit. It's going to be in the show notes. I think there's this cosmosdb.github.io site where we built these architect level 400 level labs. And these architect labs specifically go into this. How do you troubleshoot for this? So what we do is we actually have a collection and you spin up to 10,000 RUs per second to put in your documents.
Mm-hmm.
Once your document's in there, we kill it down to 400 RUs per second.
Right.
Then we try to simultaneously insert 5,000 documents by spinning off 5,000 .NET tasks in full parallel to kill the database. And so the whole point is just so you can see is returning certain error codes indicating that you're hitting throughput limits or error codes indicating that you're hitting storage limits. Again, that's on the docs.microsoft.com website. There's a documentation around that. You're right. You do have to roll retry logic in. The problem with retry logic is that, and while this is going to be very controversial to say this, Entity Framework has made us lazy. It's baked in, it's built in.
Right.
You don't ever have to think about it. So now we're thinking about stuff we don't have to think about, and it feels like, oh, Cosmos DB should do that for us. And the engineering team is more of the perspective of, we don't want to be that opinionated in our SDK.
Right. Well, Carlos, so you've proclaimed yourself as a knuckle-dragging Neanderthal DBA, right?
That's right.
And so I'd imagine, like, for you, the idea of having to write code that has to try multiple times is kind of a bit of a foreign concept, because with SQL, we just expect it to just work, right?
That's right. Well, yeah, if it errors out, the transaction is going to roll back, and I know that it didn't work, and then I'm going to get an error and have to do something with it, right?
Yeah, so it's funny you say that because we have transactions at Cosmos. And that, wow. It's funny because when I speak about Cosmos, I'm talking mostly to developer audiences.
Right.
Very few DBAs in the room. And so when I talk about transactions, I glaze over. And then we have this implicit transaction model. So if you create a store procedure using the SQL API in Cosmos, the store procedure is written in JavaScript. And in that store procedure, the start of the JavaScript function is an implicit transaction start.
Just to interject for a moment, at one point, we kind of hit on a couple of different topics. I didn't have a great way to edit that back in, so you'll apologize, and we'll start back in with Sidney talking about roles of the DBA.
The DBA's job becomes more of a performance, indexing, tuning, and I'm trying my best not to get into 400 level here, but a really good example of what a really good Cosmos DBA is doing. Just talk about SQL API and JSON here. Cosmos indexes everything by default, which is both wonderful and bad. It's great from a read perspective because every query is amazing and fast. But anytime you write to the database, you have more things to update in the index. You become the arbiter of, okay, which paths do we really need to index? What paths should we exclude from the index? Because the example I always give is if you have a JSON document with 10 properties, if you index every property, every time you write to that JSON document, writes are atomic in Cosmos. So that means all 10 JSON document properties are going to need to be updated in the index, even if they didn't change. But if you're only indexing 4 properties in a JSON document, you're doing less than half the amount of work when you're updating the index. So that significantly reduces the amount of RUs consumed by transactional create update operations.
Yeah, it will be kind of interesting to get into, right? Because I admit I'm not super familiar with Mongo either. That's something we still need to talk about on the program as well. But the idea of tracing where the data is, while we do indexing in SQL Server, it still seems like a step out, right? To be like, okay, now where are those documents and how am I going to traverse that? Maybe it shouldn't, maybe because I'm just so used to the B tree idea. It's just a little bit more ingrained, but it will be interesting to see how that works in the other platforms.
And to give you a really good example of that, I had a really long conversation with somebody at it was a partner lift in Redmond, near Microsoft's campus. And we brought in all these people who are working on Cosmos, delivering solutions. And we had this long conversation on how do you represent dates in JSON? Do you represent the epoch date using the numeric value? Do you use the string with the ISO date? If you use the string with the ISO date, are you doing a hash index where it's like a hash table? Any exact point is extremely fast. Or using a range index where you're comparing strings, looking for values between Tuesday and Thursday. Well, do we care about the date? Do we care about the hours and minutes? If we care about only the date itself and no hours and minutes, maybe we can get away with the string and do a range index. These become really interesting conversations that you can actually be the winner in your organization and say, I was able to reduce our consumption in Cosmos by half because of all the wonderful index tuning I'm doing. Give me a raise.
There you go. So maybe we don't want those containers to drop in price just yet. So we can...
Yeah, let's get our raises first, and then we can drop the containers.
I want to talk about the life of the administrator. So you mentioned already one thing that administrators would have to do, which is around tuning. But how about some of the other stuff that we, even though I'm not an administrator anymore, but we tend to do with data, like a user comes in and says, hey, I accidentally deleted all of our data for the last 3 days. Can you recover it in the next 20 minutes because I've got a meeting?
So data recovery. Yeah.
Oh, yeah. So before I answer data recovery questions, Kevin, did you want to throw any more examples at me? Because I'm actually taking notes here on. So data recovery.
Yeah, data recovery is a big one. Just backups in general, not necessarily I have 2 or 3 or 500,000 data points I want to recover, but I want to make sure that everything is there and that I can revert to a previous time if a release goes catastrophically wrong. The ability to copy data off to bring it on some other site. A lot of this becomes less important if you're using CosmosDB as a secondary caching store where the data lives for real in a primary source system somewhere else, and then you're using it here for enhancing speed. But if you want to use this as a primary system, like you don't have the data anywhere else.
Right. So I think the example, a good one that people might be asked about a lot now is like your data science folks, or I guess the BI is more traditional. They want to get access to that data, but you don't want it stomping on the transactional system, right? So they have to spread that out so that everybody can be happy.
So I got two answers to that question. The very first one around backup and recovery, that's kind of the gift and the curse of a platform as a service. You think about Azure SQL Database and the backup recovery story there, where it's mostly automated. There's some stuff you can do, but if you want to do anything beyond what the service provides, it's just involves setting up manual replication, setting up manual options. The same thing with Cosmos. There's built-in backup and recovery, but if you want to go a little bit more advanced, there are solutions there. And that kind of gets me to the second answer where you're talking about BI integrations. Well, Cosmos DB has two really interesting ways you can set up integrations, and that allows you to create more interesting BI scenarios, even backup and recovery scenarios. So the service itself has built-in backup and recovery. And that kind of is great because it's built in, but it sucks because, what do I manage? What do I configure? It's a set backup retention period. There's a set process for recovering. It's not very customizable. So I have a lot of customers who say, that's not acceptable. I want something more elegant, more sophisticated. I want to be able to report out a really common one. I have my transactional data, Azure Cosmos DB. I like to aggregate it and dump it into SQL. And then I'll use Power BI to report off of SQL for my reporting needs, which a relational database is excellent for reporting and analytical workloads. So why not use a relational database there? And so the way you do that in Cosmos DB land is you have two mechanisms. You have the change feed and the connectors. So there's connectors that feed into the various Hadoop services. Obviously, you can stand up an HD Insight instance. So there's a Spark connector. There's other connectors available. And what you can do is use those workloads to actually pop data. A really common scenario you're going to hear is I'll feed in data from Cosmos into Azure Data Factory. And then using Azure Data Factory is kind of your modern SSIS to pop the data into wherever you want to be. So if you want to aggregate and find average data, or you want to highlight certain records, not pulling everything, but pulling the records that are appropriate and put them into a data lake, SQL Data Warehouse, or even just SQL Server or the Azure SQL Database service, that is very common. And I see a lot of DBAs in that space because what you're doing is you're really crafting a solution, a little bit more intense backup recovery solution. And then on top of that, it opens up additional workloads. So a lot of times you'll see, if you actually look at the diagrams, I know they throw diagrams everywhere at conference talks. A lot of the examples they show Azure Cosmos DB as the transactional database, but then they're actually shipping data for reporting to data warehouse. So they're shipping data, using Data Factory pop data in other systems. I've seen scenarios where Data Factory ships data, then you firing off a logic app, and the logic app is putting data into SharePoint, Salesforce. I've seen scenarios popping in data warehouse, and what's the name of the service that gives you data packages that users can consume on their own and then can create their own ad hoc queries in Excel or Power BI. It's kind of like make a marketplace of data.
Oh, shoot, are you talking about data catalog or something like that?
Yep, you got it. Data catalog. I've seen that where Cosmos is the transactional database, but they're using Data Factory to take specific records out of Cosmos and put them into, I can't remember if it was a SQL database instance or a data warehouse instance. And then they surface that data using data catalog so the sales team can go look at sales data without actually seeing any PII about the actual customers themselves. So the intention is not for Cosmos to be an island, but to be just as much an integrated part of your workflow. It's a lot of, I don't know, are y'all really familiar with the concept of Lambda architecture?
Oh, yeah.
Okay. A lot of Lambda architecture diagrams you see now use Cosmos for the hot path and then use Data Warehouse for the cold path. It's super common now because the Cosmos is great for super speed queries, especially when they guarantee reads are kilobyte-sized JSON documents. By the way, that's a massive JSON document. For a 1 kilobyte-sized JSON document, they guarantee a read in under 10 milliseconds. Well, if you have geo-replication enabled. So for a transactional database hot path, that's amazing. But for the cold path where you're trying to do deeper analysis, HDM sites, SQL Data Warehouse, these are much better solutions. So it's not meant to replace your stack, but to just really be an integrated component of your stack.
So we've talked about data lake. We've talked about Cosmos consuming all of this data. Is there really a difference then between a data lake and Cosmos? Is it?
You know what? I'll put it this way. What's the difference between SQL Database and Cosmos?
I think there is a difference between Data Lake and Cosmos. They're both similar that they're kind of, what's the term? You worry about the schema later, right?
Semi-structured.
Yes.
Yeah, semi-structured. I think that's definitely a big deal. But I think one of the differences with Data Lake, if I understand it correctly, is that it's got more of that scale out capability, or at least it's designed for that. And it's based on HDFS or Web HDFS, if I remember, at least for the Azure version.
Mm-hmm.
So in my mind, even though CosmosDB and Data Lake both have scale out capabilities, Data Lake's more for really, really big kind of scale out than maybe Cosmos is. Now you could correct me. I know you were talking about how capable Cosmos is for that sort of thing.
Oh, you want me to do the sales pitch? No. I'll put it this way. Data Lake is great for storing massive quantities of data, and the amount of data that can be stored in Data Lake is orders of magnitude higher than your partition key limits in Cosmos. So you'll hit technical limits in Cosmos before you hit them in Data Lake. But then the opposite is true for transactions. On transactions off of Data Lake just aren't nearly as performant as transactions off of Cosmos. So a lot of times you see Data Lake storing the data, then you aggregate it out and perform transactions elsewhere.
I think it's interesting, one of those examples where you have to know the purpose of the tool and what your needs are, and then try to match them appropriately, rather than like, lots of different services will have similar features, but then what are the scale out costs, implications, things like that, to help you make the right decision?
Yeah, so if I had to put a one quick phrase explanation of Cosmos is a database for unstructured data that doesn't really commit to any transactional API. And so we were joking, we're talking about Data Lake, and I thought you were talking about analytics. That's why I made the joke. Well, what's really the difference between Cosmos and SQL? And their answer becomes SQL is committed to an API, Cosmos is not. There's nothing stopping the Cosmos team from implementing a relational structure and a SQL API that's all closer to SQL Server. It's just they probably don't want to compete with their own product.
Right. So it is interesting, right? So I think from a marketing perspective, one of the keynotes that passed last year was CosmosDB. We've been hearing a little bit about it, DocumentDB. And as, again, we come back to the evolution of the DBA and what's going to be happening. So one of the advantages that Cosmos has is that it, for lack of a better word, shards, right? Way better than SQL Server. Then you think, oh gosh, what am I going to be doing? I think there's always that balance there between, again, what tool you should be using, what your teams feel comfortable with.
The real story here is just it's another option. And right now, I think it's a really good option for people who are coming from outside the Microsoft ecosystem and looking at something a little bit more familiar. And I think it's going to take longer before more developers, DBAs, infrastructure people within the Microsoft ecosystem warm up to it because it's so different. Somebody like me, I'm in a world that's really AWS, JavaScript centric, Mongo centric. It just was a natural fit for me because I'm already in that world. If you're not in that world, it's not uncommon to just look at this and go, well, what in the world? Why would I ever need this? And that's perfectly fine. To put it in perspective, I know a lot of developers who work in the AWS space and the Mongo database space and the Angular, Node, React, Flux. I don't know what the other new JavaScript platforms are, but they work on these platforms and they have no idea how to do anything with MS SQL or even MySQL. That's just completely foreign to them.
Sure.
So different world.
Yeah.
Yeah, I think that Cosmos DB has a lot of promise, and it's so funny that they Frankensteined this database engine where they just keep slapping on new data models. So it'll be interesting to see where it goes, and I really hope that they add more of a lower floor for the price so that amateurs like me can do side projects and learn about it without having to spend $20 a month just to play with it.
Should we go ahead and do SQL Family?
Do it.
Sounds good.
Okay, Sidney, how did you first get started with SQL Server?
Oh, wow. When I was at college at VCU, we had a .NET class, and I had to learn this new database called SQL Server. And I thought this was a ripoff of MySQL. How would anybody ever use a knockoff product? So I learned it about 2007.
Okay, very good. Now, if you could change one thing about SQL Server, what would it be?
Today, I think the biggest thing I would change is just that's a really good question. The elastic scale capabilities in Azure SQL Database.
Yeah.
I feel like it's really difficult to figure out how to use that and to get started. It's something I'm really interested in. After researching it and doing examples, I still don't have my mind wrapped around it. So I think that learning curve needs to drop significantly.
Okay. What's the best piece of career advice you've received?
When I was in high school, I got a piece of career advice from a youth program, the leader of the youth program. We were driving down the highway. He said, when you're talking about yourself and selling yourself, you're a used car salesman for you. And so you need to get out there, wear the ugly jacket and just really convince people to invest in you, that you're the greatest person in the world, and get the car off the lot, get that job. So I've really taken that advice seriously.
Our last question for you today, Sidney. If you could have one superhero power, what would it be and why do you want it?
Oh, wow. The power to redistribute time.
Oh.
What that means is I'd like to be able to take time for the future and use it now, and take time for now and save it for the future. I work from home. I have my own consultancy. I just became a Microsoft partner. I'm a learning partner now. I've just delivered my first courses a week for this podcast. So it's really exciting. I'm about to be an application dev silver partner within a month.
Wow.
So a lot of what happens for me is that I get 2 days slam, hour to hour. For example, the day we're recording this podcast, I had a 3-hour webinar in the morning, and I have a user group meeting talk 2 hours after the podcast is done. So I like to be able to borrow some time where the rest of the week I have nothing else going on and redistribute it to today.
There you go. Interesting. Well, Sidney, thanks so much for being on the program.
Yeah, thank you for having me. I put tons of links in the show notes for tutorials, labs, white paper scenarios, plenty of reading for everybody in the audience to get deeper.
And thanks, Eugene and Kevin, as well, for jumping in today on today's program.
Glad to be here.
Definitely. It's a pleasure.
So this is going to be exciting to see what the adoption is. Again, I think there are just so many different cases or use cases that organizations have around data, and they're going to need multiple options to be able to handle them. I think it was pretty obvious from the conversation. The first customers are going to be those larger organizations that have customers all over the world. And so you could think about, banks or global organizations that have dispersed geographic needs. And then it will probably make its way down into other organizations as time goes on and as they're able to make things more affordable, things like that. So I am looking forward to seeing how this evolves. Again, how it continues to interact with those of us who are using SQL Server. I definitely don't think that we need to be using or abandoning ship with SQL Server anytime soon. It is interesting, however, for those who are considering adopting Mongo, that this may be a better opt-in or a migration strategy if you already have Mongo, to be able to get back into the Microsoft stack and play a bit nicer, if you will, with SQL Server, for example. So that will be interesting to see. So again, you can check out the show notes for today's episode. We'll be at sqldatapartners.com/cosmos. And as always, compañeros, we're very interested in what you have to say. Thoughts or comments are always appreciated. You can reach out to me on social media, particularly LinkedIn. You can connect with me. I'd love to connect with you and chat. I am at Carlos L. Chacon, and we'll see you on the SQL Trail.
SQL Data Partners.